So for the lecture, we're going to talk about three objectives. We're going to talk about the relationships between categorical items, the relationships between quantitative values, and we're going to talk about some of the methods of summarizing numbers. So let's just recap here. Any table or visualization is simply a quantitative story. A quantitative story is going to have two types of data. You have to have quantitative values, obviously. But then you could have one or more categorical items to help give some meaning to the quantitative values. So quantitative stories are just about relationships. And we've talked a lot about relationships. We're going to talk a little bit more about relationships today. So let's talk about the two types of values, quantitative values and categorical items. So quantitative values measure things. Categorical items divide and group quantitative values. You'll often hear me say slice and dice. That's what categorical items do. They serve different purposes, but they complement each other. You need them both. So in Tableau, this is a very simple relationship. You have your categorical items on the x-axis, or that's not an axis, that's a header line. Quantitative values are on your y-axis. And in Tableau, remember that categorical items are measures, quantitative values, did I mess that up? Categorical items are dimensions, quantitative values are measures, excuse me there. And remember that measures come out onto the view aggregated, which we'll talk more about that in a little bit, but dimensions come out as themselves. So in this example here, if I were to just bring out total sales first, I would just get one bar with a total aggregation for it. Not really helpful. Then when I brought out the categorical items of region, then Tableau does its thing. It slices and dices that total sales by the region. Now, if I reverse that and I just brought out my categorical items first with no quantitative value, all I would get is a list of all the different regions. Nothing measured at all. You just get a list of categorical items. So your relationships can be simple or complex. Simple relationships are just like the previous slide. It's just a relationship between quantitative values and categorical items. Complex relationships are among multiple sets of quantitative values. So this is an example of that, and it's a scatter plot, and that's your typical example of a complex relationship because you have two quantitative values. In this instance, you have profit on the x-axis and sales on the y-axis. And what's happening here is with a scatter plot, it's talking about correlation between the two, and we will get into that as well. So there are four types of relationships between categorical items. There are nominal, ordinal, interval, and hierarchical. We're going to go over each one of those one by one. So a nominal relationship means that your categorical items have no order to them at all. The values are discrete, but there's no obvious relationship amongst all the different items. So this is an example. So this is from the Global Superstore. This is just the market categorical item, and it just lists all the different values in market. All the different values, there's no order to them, and there's no relationship to them except that they all belong to market, but there's no real relationship amongst the different items. The second type of relationship of categorical items are ordinal. So this is when your items have some sort of prescribed order. First, second, or third, small, medium, or large. Here's a Tableau example. We looked at this before, where order priority. You have critical, high, medium, and low. By just reading those items, you know that there's some sort of order to that. But it's hard to measure it. That's how you know it's just it's just an order, it's just an ordinal relationship. Now, on the other hand, interval relationships also have an order, but they also have an assigned sequence of ranges. They're more measurable. However, the intervals might not necessarily be equal. And an example is the IPEDS age groups, which is in our midterm project, that data set. So here's that, here are the different age ranges. So you know there's an order, obviously under 18, then it goes to 18, 19, 20, 21, all the way to 65 and over. So you know there's definitely an order, and there's definitely some sort of way to measure that. However, the intervals are not exactly the same. Obviously, under 18, that includes age 1 to age 17, is not the same amount of time as 18 to 19. So it is an interval relationship, but the ranges are different, and that's okay. So here's a question for you. So what type of category relationship is months in a year? Keep in mind that every month has a different number of days in it. So is it ordinal or is it interval? A lot of people think that it is just ordinal, but it's interval, because you do know that they have an order, you know that, but there's also there is an assigned range of intervals between the days of the month. So 1 to 28, or 1 to 30, or 1 to 31. And remember, because you don't have to have the interval range equal for each month, that is what qualifies months in a year as interval. Okay, and our fourth categorical relationship are hierarchical relationships. These are typically considered the parent-to-child relationships, where each child in a set only has one parent. And here's an example of that, again, using the Global Superstore and Tableau. So you have your categories and your subcategories. Your subcategories are your children. The category is the parent. So furniture has several children, office supplies, several children, technology, several children. Those children are the subcategories. However, your subcategories only have one parent. So if you look up paper, you'll see that it only has one parent, and that is the category of office supplies. Okay, let's switch gears a little bit and talk about the relationship between quantitative values. And it might get confusing when you're thinking about categorical items and quantitative values, because they kind of seem the same, but they are very different. So there's three types of relationships between quantitative values: ranking, ratio, and correlation. So ranking, this is where it gets kind of confusing, because ranking is very similar to ordinal, the type of relationship for categorical items, but ranking is based on quantitative values. And you can have ascending or descending. And let me show you an example of this so you kind of get the idea. So this is exactly what we were just looking at. We know that there is no ordinal relationship in the category or subcategory categorical items. There's no order there. But in our quantitative value of sum of sales, they've been ranked. So then we do know that there is a ranking order here. So that's why this qualifies as a ranking relationship. And our second quantitative value relationship is ratio. That's typically where you take one quantitative value and divide it by another. It's typically represented as percentages. And you have two types generally. You have the parts to a whole comparison, which we've talked about before, and we also have a measure of change. So this is the parts to a whole comparison. You know it's parts to a whole. One, because you've seen this type of visualization before. It's the touching bars method of representing parts to a whole. But you also know, if you didn't recognize this type, if you added up all of those percentages, it will equal 100. So that's how you know it's a parts to a whole. Now this one, in comparison, it's still a ratio relationship, but this is the measures of change. If you look at the top line graph, that's just simply total sales over time. Okay. The second one, though, that's where it's a little bit different. You notice it's a percentage, and it's percentage difference in sales. So it is just the percentage difference from the previous year, which is why you don't see any value for 2011, because there is no 2010 to compare it to. So this is the ratio relationship. And now let's look at correlation. This is our third type of quantitative value relationship. This represents a correspondence of change between two quantitative values. And we're going to look at that scatter plot again. Scatter plots are always representations of correlations. So when profit goes up, what happens to sales? That is the key here. That's what we're visualizing here. So when one value in a data set changes, how does that affect the corresponding value in the other quantitative set? Okay, and finally, let's get into aggregation a little bit. Aggregation, I'll say aggregation a lot, but it's basically just summarization. It's a higher level, not granular, so we're not looking at individual values. You tend to see this more in visualizations rather than tables, and it's more useful in understanding trends and patterns. And I'm going to show you an example of each. So it's just as a review, this is a table, and that's obvious, but what is the advantage for using the table in this instance? Well, I would say that the advantage is that you can look up individual values and you can compare individual values. That is the advantage to this one. On the other hand, you can represent the same data as a visualization. And in this instance, you got the same data, but it's easier to look at overall trends and comparisons between the aggregations. So that's why sometimes you're going to choose a table, sometimes you're going to choose a graph or a chart. And let's look at all the different types of aggregations. So we have measures of central tendency. That's the one you're going to see most frequently, and probably the one you're going to be dealing with the most in this course. There's also measures of variation, measures of correlation, measures of ratio, and then measures of money. So let's start with measures of central tendency. You have the mean or the average, you have the median, you have the mode, and you have mid-range. The mean or the average, most commonly used, I think everybody pretty much is familiar with this. You sum up all the values and then you divide it by the number of values. And it takes all values into account. And as a result, it is very sensitive to extremes. So if you have a set of quantitative values where you may have the majority of your values all in one specific range, but then you have 2 or 3 values that are way outside of your range, either above or below, your mean is going to be affected by that. That's why sometimes when companies promote or advertise their average average salary for their employees, well, they may have a few very high-ranking people in their organization who make obscene amounts of money, but then the majority of their employees make, regular average salaries. And if you take the average of all those, it's going to look like that company pays their employees quite a bit if they use the average, because it takes into account those very few individuals who are making a large amount of money in comparison to the majority of your employees who don't make that much. So that's why you have to be kind of careful when you're looking at the mean. It's not always an accurate representation. So in Tableau, typically when you bring a quantitative value or a measure out onto your view or your visualization, it's going to aggregate it using sum. That's the default. You can change that very easily by just right-clicking on the green pill and then going down to where it says measure sum, and then going over, you have a bunch of different options on how to aggregate your green pill or your measure. So in this case, average is your second choice. Okay, the second measure of central tendency is median. Not used as frequently as mean, but it's not as sensitive to extremes. And the median is basically the middle value of an ordered set of values. So you first have to order your set, and then you pick the middle value. And if you have an even number of values, obviously you won't have one middle value. To be able to figure out the mean, you have to take the average, or to figure out the median, excuse me, you have to take the average of the two middle values when you have an even number of values in your set. So this is the same thing that I showed you a couple slides ago. If you want to change from average to median, just right click on your green pill, go down to measure average, and then over to median. Okay, your third measure of central tendency is the mode. The mode is rarely used, and it's basically the value that appears most in a set of values. And there's something that's called bimodal, and that means that you have two values that appear twice in a set, and no other values appear more than once. Basically, it means that you have two groupings in your data. And this is one example is you may have peak restaurant hours, where you have a peak at lunchtime and a peak at dinner time. So that would be considered a bimodal distribution. And then finally, your fourth measure of central tendency is mid-range. Again, this is rarely used, but it's the top value plus the bottom value divided by 2. And essentially, it's just a very quick method of doing a mean or an average. But just like the mean or the average, it's very sensitive to extremes, obviously, because you're taking the top value and your bottom value. Okay, so let's switch gears from central tendency to measures of variation. And there's two types of measures of variation. There's spread and there's standard deviation. So the spread just means your highest value minus your lowest value. And again, just like mean and just like mid-range, very sensitive to extremes, because again, you're taking a highest value and a lowest value. There's also the standard deviation. And we're not going to get a whole lot into statistics in this course. I'm assuming most of you will probably take a statistics course before you graduate. So I'm not going to get into a great deal of this because we're not going to use it a whole lot. But standard deviation is the variation of a set of values relative to your mean. The larger your standard deviation, the greater your variance. And a visual representation of the standard deviation is a frequency polygon or histogram. Now, a side note, if you have a bell curve, that's the representation of a normal distribution. So 68% of your values fall within one standard deviation of the mean. 95% fall within 2 standard deviations. 99.7% fall within 3 standard deviations. And this isn't a perfect bell curve. It's not a perfect normal distribution, but it kind of gives you an idea of how it looks. You probably have seen the bell curve before. But this is something that was done with Tableau, and it's easily done. And it just represents for each customer, which is represented by the customer name, a count of them. It shows how many fall within a grouping of orders. Okay. Third type of aggregation, measures of correlation. That's going to be your linear correlation coefficient. And what that is, it measures the direction and the degree of the linear relationships between two pairs of quantitative values. So when we talk about two pairs of quantitative values, remember we're probably going to be talking about a scatter plot if we're visualizing this. But you have a positive correlation, which means when one value increases, the other value also increases. And then a negative correlation is just the opposite. When one value increases, the other decreases. So here's an example of this. So is this going to be a positive or a negative correlation? Well, the line, which is going to show the trend, is going from the upper left to the lower right. So it is a negative correlation. So you can see when the discount goes up, the profit generally goes down. Just a little bit more about linear correlation. All values are going to be between +1 and -1. 0 means there's absolutely no correlation. +1 is a perfect positive linear correlation. -1 is a perfect negative linear correlation. The greater the value, the stronger the correlation, and that can mean either plus or minus. And the most recognized visual representation of linear correlation is a scatter plot. Don't necessarily have to have the trend line, although it does help with visualization. And then just keep in mind that not all correlations are linear. Okay, the fourth type of aggregation is measures of ratio. And these are relationships between single pairs of values. They're shown different ways, just depending upon the frame of reference. It could be a division, like 2 divided by 5. It could be 0.4. It could be 40%. Here's an example of that. The net profit ratio, net profit margin. So this is a profitability ratio, and it's a calculation where you take your net income divided by your net sales. It's generally shown as a percentage. And let me show you an example. So your net profit margin is on the bottom, and that is calculated by taking the net income divided by the revenue. So that gives you your net profit margin. And finally, our last type of aggregation is measures of money. The only thing I'm going to talk about that is just make sure that if you're using a currency, that you account for different currencies. If you are doing analytics for a global company, for example, you may have currencies in all different, from all over the world. So you have to convert those. They all have to be standardized. So that can affect, you can't throw the currency for one country against the currency for another and expect to see anything from that without doing some sort of conversion. And the second thing you always have to consider, if you're tracking this over time, you probably should adjust for inflation or deflation. So keep that in mind if you plan to be doing any sort of analytics in the financial market or for a global company. You have to keep all these things in mind. And then finally, I'm just going to sum up this lecture to kind of give you a preview of what we're going to be doing in the exercise. So we're going to be doing a lot of calculations in this module in Tableau. And this is that calculation screen. And you've seen this before already. We've touched on it a bit. But I'm going to just go over the parts with you pretty quickly, and then we'll put it to practice. So always make sure you title your calculations well. You don't know how many times I've seen people title calculations in something that doesn't make any sense, and then later on when I'm trying to find the calculation in my list of measures, I can't find it. So make sure that you title them well. Of course, you know the area where your calculation goes. We'll practice more typing them out instead of just copying and paste. Make sure you always check your validity at the bottom left. If everything's okay, it's going to be gray. If it's wrong, it's going to be red. And if you hover over it, it's going to tell you what's wrong. Although sometimes Tableau isn't very specific, so sometimes you have to kind of do a little bit more research. Always make sure that you click apply or OK when you're done. If you click apply, it just, if you already have your calculation on your view or your visualization screen, it's going to show up on your screen. So you're going to be able to immediately see what happened with your calculation, if it worked or if it didn't work. If you click OK, what's going to happen is it's going to close out your calculation screen, and then you'll see your results. So if you anticipate that you might need to tweak your calculation, it's always probably best to click apply rather than OK. One thing that you make sure that you don't do, which I have done on occasion, and it's very frustrating, is you click the X button. And I don't know why I have the tendency to do that, but that's very frustrating after you spent a few minutes getting the right calculation working, and then you lose it all if you click on the X. So be careful about that. And then if you ever need some help in either finding a function or a calculation that will work for what you want to do, if you click on the little flyout button on the right of the calculation screen, you'll get this little gray section here that you can search for different expressions, and you can find out what they mean, and they typically give you an example of what it does as well. So so that's just a preview. Next step is to go to the exercise video. We will cover some very basic calculations. I'm first going to talk a little bit about table calculations, and then we'll go more into calculations that you do yourself by hand in Tableau. And everything that I cover, again, in the exercise video, you'll be using in your graded exercise for this module. So thank you, and I will see you in the next video.